Good afternoon. Today is we're going to learn something new today, okay? So it's mechanical engineering, 2Q04, and today is week 03, and it's on a Friday. Okay, it's on a Friday, and then from here we're going to do a example agenda for today. We're going to work on a example on calculating transient state performance measure. And then after that, we are going to a new topic. And this new topic will be in your term test. And it is known as a planar kinematics of a rigid body. Okay, I want to introduce you to this topic, and we're going to state some rules on this topic. And this topic, I'll show you. I'll give you a quick preview what we are going to handle. We are going to handle problems like this, okay, where we have a pulley, we have a weight, okay, we have things like given velocity, acceleration, we want s to be equal to 0.5, we have to determine the speed of the block, okay, and how we're going to calculate it, okay. It is normal to see questions like this, and for the first time you see it, you get overwhelmed, okay. It is normal. Because when I saw it the first time I was on the undergrad, I get overwhelmed, okay? But I'm going to teach you in such a way that I'll make you think about the solution procedure. Write down the formula, okay? Think about the solution procedure. What are the key factors to consider and solving it? It's not that bad, okay? If it's that bad, I wouldn't do it. Are we clear? Okay, right. So coming back to our favorite. So by now, you all should be like very like familiar with vibration now. Okay, this is the last example that I'm going to give. Okay, so now given to us, determine the rise time, peak time, percentage overshoot, subsidence ratio, and settling time. Just a bit of hint of your midterm, okay, of your term test one, something very similar like this will come out. Okay, I repeat again, something very similar. Okay, and I'm going to show you what are the expectation. Again, my answer are closed. Okay, folks here, a formula sheet. You will have formula sheet. Monday you will get a sample of your formula sheet. Are we clear? Okay, so okay, nothing again from here. So I'm going to apply what I preached yesterday. Okay. So the first thing of all, we know that this is a spring mass system. So m d squared x over dt squared plus by c dx by dt plus by kx. A student earlier told me, seen all the formula, but when work on the problem, seems to be overwhelming. Hey, I had the same feeling when I just started. It is normal. Okay, you only seen equation of vibration over the past 2 weeks. Are we clear? Okay, But don't let the fear of overwhelm prevent you from doing questions like this. It's not that bad. Okay, it's not that bad. So from here, we know the mass. So you just start filling in numbers, right? You know the mass is 9.072 d squared x over dt squared, plus by the c is 50 dx by dt, plus by the k is 1250x, and the whole thing is equal to 0. Okay. So the thing that we have to check, we have to find, or we have to determine what is our c squared and 4mk. And some of you will, Eugene, why we have to determine our c squared and 4mk? Because our roots, our beta for our roots will be equal to what? C squared minus 4mk over what? 2m, right? If this thing goes to negative, right, it means that we have a underdamped system. Okay, so the checking of the first place is check your c squared 4mk, and I just show you why c squared 4mk. Okay, so you do your c squared. So c over here is 50 squared. So 50 squared is 2,500. Then the next thing is you have your 4mk. So you have your 4, your mass, and your stiffness is 1250. So this will be equal to 4 times 9.072 times 1250. We have 45360. Okay, help me check. Okay, I can be wrong. Okay. Okay, 45. Did I start recording? I did. Stop digging your nose. Sorry. So sorry. I should not be doing that. Right. So we just show that what? We just saying that p squared, right, is less than 4mk. So we just realized that this term will become negative, yes or no? So we immediately know that the general solution will be given is x as a function of time, e minus alpha t, c1 cos omega t, plus by c2 sine omega t. Okay. At the same time, I'll do a very quick revision for you guys. So the first thing that we can figure out now, okay, is we know what is our omega n. Omega n is equal to square root k over m. So k is equal to 1250. And our mass is 9.072. So when you compute this, so 1250, 9.072, okay, square root of the whole thing is 11.738. 11.738 radians per second. Okay. And the next thing that we know, we also need to calculate what is our omega. Okay. So this I will put, this is our natural frequency. And sometimes in your textbook, they use the word resonant frequency. It's the same thing. I do apologize, I did not mention that. I know the textbook used resonant frequency. It's the same thing. So omega n is your natural. So we know, the next thing that we know is we know that we are going to find omega. So omega is just equal to square root of 4mk. Let me do a small square root first. 4mk minus by c squared divided by 2m. So where did this come from? Right, Eugene, where did this come from? Remember, when we discovered that c squared, right, is less than 4mk, we know that this is not a possible solution, right? A square root of a negative number is not possible. So what we do is we flip it over, yes or no? Then it becomes positive, then it's a possible solution. Then from here, omega n is equal to 4mk. So I'm going to introduce the 2m inside, right? So we have square root, the whole thing, 4mk divided by 4m squared, right? Minus by c squared over 4m squared. Okay. And then what I'm going to do is I don't want to skip step. I know yesterday when I was doing it, I skipped steps, so some of you are a bit confused. I will put 4mk over 4m squared, right? Minus by k c squared divided by k, or divide by 4m squared k. Okay. And why do we want to do that is because I'm going to have a common term, k over m. And then this will become cancel, cancel, this one cancel, cancel. So this will become 1 minus by c squared over 4mk. So the next thing we're going to do, we're going to let zeta is equal to square root of c squared over 4mk. Okay. Okay. We are going to let square root of c squared over 4mk. So this can be also be equal to zeta squared is equal to c squared over 4mk. So with this, we know this can be written as square root k over m, then square root of 1 minus by zeta squared. Okay, so this will be equal to omega n square root of 1 minus zeta squared. So from here, we know that omega, okay, omega, so therefore, omega, by the way, this is also equal to omega d. And omega d is your damped natural frequency. Okay. And we also know that omega n, right, will be always greater than omega d. Omega n, the resonant frequency, when it's the natural frequency is always greater than the omega d. Okay. And this is because over here, this factor over here what you see here, this factor over here, right? This term over here will always be less than what? 1. Okay.